Welcome to this explainer. Today, we're diving straight into the foundational architecture of network security. We're going to use some core principles directly from the CompTIA Security Plus exam to show you exactly how modern enterprise networks are actually built. So think of it not just as, connecting a bunch of computers together, but as constructing a highly secure, heavily guarded physical facility. But before we even start looking at the specific blueprints and diagrams, we really have to ask the ultimate question that drives all of this security architecture in the first place. How do you build a network that actually keeps adversaries out of your sensitive data? Because, as you probably know, it's not just about blindly throwing firewalls at a problem. It is about highly intentional, structured design.
So here is our blueprint for today. We'll be covering 1. The network foundation, 2. Physical and air-gapped isolation, 3. Logical network segmentation, 4. Software-defined networking, 5. On-premises network architecture, and 6. Centralized versus decentralized systems. Let's just dive right into the tour.
Section 1. The network foundation. To get us all on the exact same page right off the bat, your network infrastructure is simply the underlying communication paths and services. It is literally the hardware and the software that allows your devices, users, automated processes, and even external networks to talk to each other. Without this solid base, you just don't have a network to secure. It's the plumbing and the wiring of our secure facility. Section 2. Physical and air-gapped isolation. Now that we've got our foundation poured, let's talk about building actual physical walls to protect our absolute most sensitive assets. Physical isolation restricts access in the most literal sense you can imagine. Say you have incredibly sensitive data servers. You aren't just going to slap a password on them. You place them in a secured, locked room. You use completely distinct physical cables, dedicated network switches, and hardware firewalls that touch absolutely nothing else in the entire building. You are creating a secure enclave, drastically minimizing potential risks just by being physically separated from the rest of the company. But what if you want to take that physical isolation to the absolute extreme? What if you build an air-gapped system, meaning there is literally a physical gap of air between this computer and any other network in the world? How do you hack a computer that has zero connection to the outside? Well, the answer is surprisingly low-tech. Hackers literally have to cross the air gap. To compromise that machine, a bad actor has to physically walk right into the room and sit down in front of the keyboard. This is exactly why managing an air-gapped system isn't about configuring complex firewalls. It's about disabling physical ports on the machine itself and strictly banning USB thumb drives to stop localized data theft and viruses in their tracks.
Section 3. Logical network segmentation.
Okay, moving on from those thick physical walls, let's look at how we create invisible partitions inside the exact same physical space. The core difference here is pretty cool. While physical isolation needs entirely separate gear and rooms, logical segmentation does all the heavy lifting via software. It divides a single physical infrastructure into secure, separate segments based on functionality, departments, or specific security needs. So you save big on hardware, but you still keep that critical separation. Let's look at an example. You've got human resources, finance, and R&D. They might all be sitting on the exact same floor, plugging into the same physical switches and sharing the exact same cables. But logical segmentation places them in separate virtual local area networks, or VLANs. Because of this software configuration, HR absolutely cannot see finance's data, and finance cannot peek into R&D secret projects. They're operating as completely isolated networks, even though they share the same physical foundation. Pretty brilliant, right? Section 4. Software-defined networking. Next up on the facility tour, we're stepping into the modern, high-tech control room of our blueprint. Software-defined networking, or SDN, radically changes how networks operate by decoupling the brain, which we call the control plane, from the muscle, the data plane. In traditional networking, every router and switch was just its own little island. Admins had to manage them one by one using command line interfaces, clunky GUIs, or custom scripts. But with SDN, we actually pull the brain right out of the individual devices and put it into a centralized programmable controller. This controller calculates the best paths and simply sends flow instructions down to the switches to do the heavy lifting. The industry documentation highlights just how massive this architectural shift is. It's a complete move away from a semi-intelligent distributed model, where devices were essentially just figuring things out locally, to a highly efficient, central, and intelligent system.
this central controller oversees the entire infrastructure all at once, which means you get massive scalability and you can rapidly reconfigure things without ever touching a single physical cable.
And this centralized intelligence is actively powering the industry right now through some major projects. Open vSwitch, or OVS, is huge for this, using OVSDB and OpenFlow protocols to manage virtual switches. Then you've got Cisco APIC, which is the absolute core of the Cisco application-centric infrastructure framework. And open source initiatives like Open Daylight are out there advancing vendor interoperability and collaborating with OpenStack Neutron, so you don't end up locked into just one hardware brand. Building directly on that SDN concept, we also have software-defined visibility, or SDV. So while SDN routes the traffic, SDV is built specifically to let you see it. By utilizing RESTful APIs, it orchestrates operations and gives administrators incredibly granular, detailed insights into network activity. Whether your network is sitting on-premise or out in the cloud, SDV shines a massive spotlight on exactly what your data is doing. Section 5. On-premises network architecture. Speaking of where things live, let's step back for a second and look at the physical location of this entire secure facility. Today, cloud setups hosted by third-party providers are absolutely everywhere. But an on-prem build is a different beast entirely. It means you house and manage every single server, cable, and software license locally within your own four walls. You have absolute, complete control. This is fantastic if you have strict regulatory compliance needs, or if you require intense customization. But the trade-off? It takes dedicated personnel, specialized equipment, and much higher upfront costs to manage everything yourself. Section 6. Centralized versus decentralized systems. As we wrap up our blueprint review, let's look at who actually holds the administrative keys to the facility. A centralized system means only one entity, like your core IT department, grants access or makes uniform decisions. This consolidated control is great for consistency, but it can create major bottlenecks and, honestly, a single point of failure. Decentralized systems, on the other hand, distribute that control much closer to the actual resources. This gives you higher resilience and greater autonomy, but it definitely makes coordinating security policies a lot more complex. Which brings us to a really critical decision for your own security blueprint. You have to weigh that natural friction between absolute consistency and agile resilience. Based on your organization's size, its geographical spread, and your specific performance needs, would you choose a centralized brain or a decentralized system to secure your data? There is no one-size-fits-all answer here, only the architecture that fits your unique needs. Thank you so much for joining me in this explainer to unpack the physical and logical building blocks of modern security architecture. From pouring the concrete with foundational network infrastructure, to building air-gapped vaults and weaving invisible VLAN partitions, right up to programming the SDN control room, these are the blueprints that keep the modern digital world safe. The real question to leave you with is this: as adversaries get smarter and faster, is your network's architectural blueprint actually keeping pace with the threats? Keep building those secure foundations, and I'll catch you next time.